Hi class, I was helping Noah with his homework and I realized that this homework assignment might have been a little bit harder than I thought. So I'm going to go through these homework problems. I want you, even if you got it, to watch the video just to make sure that you're doing things correctly. I'll try to do the easier problems quicker and the harder problems longer. So as you can see here, we have, make sure my pen can write. The first one should have been pretty easy. It says just classify each of the following angles as acute, right, obtuse, or straight. So you can see we have, whoops, I just moved it instead of writing on it. Hold on a second, let me get my pen. Hopefully this works. Hold on a second. Okay, so you have TOM. Okay, having a little technical difficulties here. See if I can write over here. Let me just see something here. Okay, so we have TOM. So if you look on the picture, you don't even have to use your protractor. You can see TOM right here. I don't know if you can see when I have the little blue dot, so let me just draw it. So you have TOM, and all you have to do is say what kind of angle is it. Is it obtuse, acute, or straight? And you can tell that one's acute. So you would just write in your notebooks or wherever you're writing this, you would just write, let's see, my equipment's getting old here, it's having some trouble. You would just write acute. One second. So you would just write on your notebooks, you would just write acute for that one like that. So these first ones should be pretty easy. This one, LOM, I think that's somewhere. The second one, actually, you can see it's a straight angle. Maybe you can't see that. This one right here, LOM, that's called a straight angle because it's 180 degrees, so you would just write straight for that one. And then I'm sure there's obtuse ones here too, like, let's see, ROS. Now this ROS, as you can look on that, that's acute. MOR, MOR, so that's a good one here. So we have MOR. That one is obtuse, so you would write obtuse. So the first part of this should have been pretty easy for you. You just use the protractor that they give you. You'll notice the way that they write things. I don't know if it was real clear in class, but when they just have like this, an angle, TOM, like that, without an M before it, it just means the actual angle, not the measure of the angle. All right, if they want the measure of the angle, like what is the measure, they would have an M in front of it, and then you would do your TOM, and you would see that it's about 25 degrees right there. So you'd say the measure of angle TOM is 25 degrees, like that. Okay, let's move on to the ones that are more complicated. 2 and on, you want to draw a picture of what they're telling you. In case you don't know what to do, you draw a picture. So this one is point P is between HG. So you're going to draw a line. So we're going to have point P. Oops, point P is between H and G. So you have H and you have G. Point P is in between them. PG is 5. So this one, we'll put the P right there. It's in between. This one's 5 and this one's 3. And they want you to find HG. So all you would do is add those two together and you would say the measure of HG equals 8. So you just add them up. So that's number 2. Okay, number 3. I have a little bit of delay because I'm on the internet. I'm using WizIQ's board and there's a little internet delay, unfortunately. Okay, PL lies, that's ray, with this means array. So when you see that over top, so when you have a PL with the symbol over top of it, you would say ray PL. We have to learn how to say things right, how to read things. Geometry is its own language. So ray PL lies in the interior of angle RPH. So let's just draw ourselves RPH. We don't know if it's going to be an obtuse angle or an acute angle. We don't know that. I'm just going to put points at the end. So we're just going to draw, I just always draw these nice acute angles. So this is R, P, H. So it's telling us that PL lies in the interior. We don't know anything about that yet, I don't believe. So it says it lies in the interior. So I'm going to put a ray starting at P to, and I'm going to draw it out like this, and this is L. So that's a ray in the interior of an angle. Now it's telling us that the measure of RPL is x minus 5. So we have RPL is x minus 5, and I'm going to actually fill that in. And then it tells us that LPH is 2x plus 18. Then it tells us that the measure of the big angle, now you can see when it's a measure, it's going to have that m in front of it. So the measure of HPR is 58. So if we're going to find out, they want the smallest angle, but to find the smallest angle, first we have to find x. So we know that if we add our two interior angles together, x minus 5 plus 2x plus 18, that has to equal 58. So we continue to solve that, so we're going to get 3x plus 13 equals 58. And then we go on to solve it. 3x equals 45, x equals 15. Now they want to know what the smaller angle is, and it would obviously be this one. So make sure you finish and answer the question. So it's going to be 15 minus 5 equals 10 would be the smallest angle, would be 10 degrees. And oops, did I skip 3? I skipped 3. I went right on to 4. This was 4. Okay, let's look at 3 real quick. Might be really easy. M, I, and Z are collinear. So this is like the first one. That means they lie on the same line if they're collinear. Let's see. M, I, Z are collinear. IZ is 8. MI is 11. And MZ is 3. And you can see that the 8 and the 3 add up to 11. So this would have to be M, and this would have to be I. Z would have to be the middle point. So MI is 11. IZ is 8. And MZ, whoops, I didn't put that in the right place. We'll put this here. We'll call that Z, and MZ is 3. And that would make MI be 11. So which point's between the other two? It has to be the Z. Okay, let's move on to the next ones. All right, these are a little bit harder to see. We have these first ones are a little bit more complicated. The other ones won't take us as much time. Okay, 5. This one says XY bisects RS. So we have to know what bisect means. So let's make line segment RS, and XY, this is RS, like that, and XY bisects it. And what it means by bisecting, whenever you see it, it's going to be a segment that divides RS in half. So here we go. This is XY. This is really segment. I think they forgot their segment line. All right, if it bisects it, what it means is it's going to divide RS exactly in half. And the way we show something's divided in half is we write these little hash marks. So we start with one hash mark here and one hash mark here. And if these two are going to be equal, they're not. We put 2 hash marks to show that they're equal to each other, but not necessarily equal to this one. So it's saying that it bisects, this one, XY bisects segment RS, and it's telling us that at point M. So this is where it bisects. That means middle, right in the middle. They're telling us that RM is 6, and they want us to find the length of RS. Well, if RM is 6, and MS is the same, this one's also going to be 6. So we know that the measure of RS, we don't put the symbol on top of it, because we're talking measure, equals 12. And we don't have units in geometry. We rarely use units unless we're doing like area and volume. Okay, let's try another one. 6. Ray, remember I talked about how when this symbol is on top of there, we'd say ray, even though I just covered it up. Ray PQ bisects HPJ. HPJ is 84 degrees, so let's just make that angle. Here we go, like this. Draw yourself pictures for geometry. This is going to be HP. The middle letter is always the vertex. The vertex is this point in an angle. APJ, there we go, and PQ is going to bisect it. And this is the same thing. If there's a ray that bisects an angle, so this is a ray and it's PQ. If it bisects the angle, it means that these two angles are going to be equal. So we can put those markings in there. PQ bisects it. If the big angle HPJ is 84, then they want to know what QPJ is. Well, if the whole thing is 84, that whole thing is 84, and PQ bisects it, which means it's going to divide it in half, it means that this one is 42 and this angle is 42. So they're both going to be 42 degrees. All right, 7. Same idea. BP bisects ABC. So let's just make ABC. We don't know if it's going to be acute or if it's obtuse, so I tend to make mine all like the same. So this is A, B, C, and ray BP bisects it. So if a ray is going to bisect an angle, it means it's going to divide the angle into 2 equal or congruent parts. You can interchange equals and congruent. Okay, so ABP, the top one, is 4x plus 5. So I'm going to write that in there, 4x plus 5. And the other one is 3x plus 15. Oops. And they tell us that, they say classify angle ABC if it's acute, right, or obtuse. Now, we know that this angle equals this angle because it tells us that this ray bisected the angle. So we know that 4x plus 5 is equal to 3x plus 15. And we're going to solve that. These are really easy to solve. So you get x equals equals 10. Subtract 5. And then when we put them in, we can see what they are. You would say 4 times 10 would be 40, plus 5 would be, this is going to be 45, and this one's going to be 45. So this, even though I drew it as an acute angle, we would say it's going to be a right angle because 45 and 45 is 90. I'm going to run out of room here. All right, 8. If R is the midpoint of XY, find the length of XY. So let's do this. Let's just draw the segment. The segment is XY. And there's R is the midpoint, which means it's going to be right in the middle. It's R. And so that means it's going to divide it into 2 equal segments. So XR is 3A plus 1, and the other side is YR is 16 minus 2A. Find the length of XY. Well, this is the same thing. You're going to set these two equal and solve it, and then you find out what one side is and then find out the other side. So I don't think we need to go through too much more work with that one. Here's another one. In the accompanying diagram, pairs of angles and segments are indicated as congruent. Use letters in the diagram to write congruence relations. Okay, so this is just a matter of writing things out with the right symbols. So here we go. 9. I'm not going to do all of these, but we know that angle PEY, so we're going to write angle PEY is congruent. That looks more like an X, doesn't it? PEY, or we could have said SEY. Either one works. You can name them either this way, or you can even name them the smaller way. And then it's the same as this one is equal to this one. So we'd say it's congruent to angle ASI. So you're just going to go and write all the congruence relationships. So we would say EAI is congruent to PHS. And you would do the same with the segments. You would say now I can't see what I wrote here. You would say I think that's Y. You would put the segment line when you use the congruence is congruent to AS, segment AS. When you use the congruence symbol, you put the line over the segment. If you're going to use the equal symbol, you do not put the line over the segment. This refers to an actual distance, like 3 equals 3. This is just the image. The EY fits exactly on top of AS no matter how long it is. That's confusing, but you'll get that as time goes on. Okay, let's quickly do the next ones. This is taking way too long. You have to use a diagram and any information to mark the diagram. So this is pretty easy. BF bisects AC. So here's BF bisects AC. So this is what you would do. Just put your congruent symbols down. So you're just going to mark it that they're equal. Because BF bisects it means it divides it into two parts. Okay, PT, which we don't have drawn on here yet, PT bisects angle STO. So you would just put, if it bisects that angle, it divides it into two congruent angles. AC bisects BD. So AC bisects BD. So this is going to be congruent to this. And BD bisects angle ADC. So this is going to be congruent to this. That's how you mark the symbols in the diagram. Okay, next. I think the last ones are going to be a lot quicker than the ones I just did. Okay, so this one you have to tell. The directions say in the exercises, justify the conclusion by identifying the property used to draw the conclusion as reflexive, transitive, symmetric, or substitution. So they give you only a few to pick from. They say you can pick from reflexive, reflexive. It's hard because I'm too far away from my internet and this isn't working really good. Reflexive, symmetric. We have transitive, which is my favorite. Transitive. And we have substitution. It seems like they use more than this though, unless it's for the other page. Yeah. Okay, this is the easy one. Now remember, reflexive is just A equals A. Symmetric is A plus B equals B plus A. Transitive is A then B. Whoops. Let me just rewrite that. A equals B. B equals C, then A equals C. And substitution is kind of like transitive. You would just substitute, and I'll show you that when we hit it. Okay, so the first one is LM is congruent to GH. GH is congruent to FG. So what tells us if LM is congruent to this, and this is congruent to this, then this, the first one, is congruent to the last one, and that's a transitive. If A equals B and B equals C, then the first equals the last. So you would say the transitive property. So you just write transitive. All right, the next one. This one is a quadrilateral, and it says AC equals AC. The C is down there. So AC equals AC. So that's the same thing, A equals A. AC equals AC. Congruent, this all works the same with congruence. equals and congruence are the same properties. These are all congruent, so I'll put the congruent symbols. So this one would just be reflexive because it's the same thing on both sides of the congruent sign. All right, next one, TW bisects STV, and I already put the markings in here. And they also tell us 1 is congruent to 3. Well, we know 1 is congruent to 3, and because we found this out, we would say angle 2 is congruent to angle, whoops, not equal, is congruent to angle 1. So this is the same thing. If 1 is congruent to 2 and 1 is congruent to 3, then 2 is congruent to 3. Well, this is substitution. You can get away with transitive for this as well, but since 2 is congruent to 1, you can substitute, instead of the 1, you can put in the 3 here. It's just substitution. Okay, this one says angle 1 and angle 2 equal 90. Angle 1 equals angle 3. How can you say angle 3 equals angle 3 plus angle 2 equals 90? Well, that's substitution too. Instead of this 1 right here, you can put, since 1 equals 3, you can substitute the 3 right in here, and so you would have measure of angle 3 plus the measure of angle 2 equals 90. Okay, now this one, what property of equality you use. So this one says, let me just get on the right page. So you have to tell the property of equality here. So let's try this. Now we're going to talk about the addition, the subtraction. Those are the properties of equality that we didn't really get to last time. So I'm going to stop the video right here. I think it's getting kind of long, and we'll do the rest on another video, if I can figure out how to stop this video.